In this video, I'm going to be taking a look at Dmitri Mendeleev, who I have a picture of him here, and he was a Russian chemist, and he did a lot of work on the periodic table. And this is a version of the periodic table which he created at around in around 1869, so like 150 years ago. Now, Dmitri Mendeleev was one of the brilliant chemists who devised a representation of the relationship between elements through this periodic table, and he's considered to be the father of the modern periodic table, because he did so much in terms of the contribution, in terms of the actual layout and the predictions which he made, and which we actually have a lot of those sort of underlying trends in our new periodic table. Now, Dmitri Mendeleev created the periodic table, and he used the elements which they had at that time, because not all of the elements had been discovered, and probably they still haven't all been discovered. But with the elements that had been discovered at that time, he constructed a table, and this table actually made him quite famous around the world, internationally. And anyway, back to this. If we take a look at this table, right, we actually have the elements along here. So we have elements, and they're split up into different rows. So we've got the rows, and we have the columns as well. And if you look at this list down here, we've got lithium. So let me choose a color that you guys can see. Lithium, sodium, potassium, rubidium, and all of these are in group 1. So you can see this is a sort of trend which has been listed here. And we've got lithium and beryllium, boron, carbon. And if we take a look at the modern periodic table, which I've got here, lithium, beryllium, boron, carbon. So he listed them in order of atomic weight, just like John Newlands did when he was doing his law of octaves thing. So this is what he did. And well, one of the things which set him apart from a lot of the chemists which were around at his time, which were working on the periodic trends which were arising, was that he actually left gaps in his table. If you look at these dashed lines which I've indicated with the red squiggles in my table here, those indicate where there's been dashes, and what these dashes mean is that Mendeleev had predicted that there's some unknown elements which should be in those slots. Now, the elements hadn't been discovered yet, but he had this inkling that those elements are going to be discovered and they're going to be placed in those spaces. Now, a lot of them he got right, and some of them he got wrong, but it was still a breakthrough in terms of the prediction of new elements, because this wasn't something that every chemist did. Now, looking at this area here, right, what we have is a dash and we have a 44, and this is an element which he predicted the existence of, but it hadn't yet been discovered. But what he did is he not only predicted the relative atomic mass of that element, which is written here, he also predicted some of the properties. And when that element was discovered, and some of these other elements like this one and this one, when they were discovered, it was found that a lot of the properties of those elements were very, very, very close to the predictions that Mendeleev had made of those properties, without even seeing the elements he had predicted this stuff. So this is one of those things that really set him apart from other chemists. And now this element here, which he predicted it had 44 relative atomic mass, or atomic weight of 44, corresponds to let's see, 44. This corresponds to scandium, which I have here. And if we take a look again at the periodic table, we have one here which says 68 and one that says 72. So if I actually go back to the periodic table, 68 and 72, we have actually one which is very close to 68. It's 69.7, and that's gallium. So he predicted the existence of gallium, and 72, which was actually germanium here. So he predicted the existence of those two elements without even knowing without them having been discovered yet. So these are some of the things which, you know, after they were discovered, that proved that was more scientific evidence backing up his idea that this trend worked the way it did. And so yeah, this is one of the things that Mendeleev did, and he did a lot of other things. He did some illegal things which he kind of got away with. I won't go into any of that stuff. And yeah, in my next video, I'm going to be talking about how Mendeleev's table was sort of expanded to make the modern periodic table which we have around today. And in doing that, I'll probably talk about some more scientists as well. So I hope you guys found this video helpful, and I'll see you guys in the next video.